learners, I welcome you all to this video program on oceanic circulations, ocean currents. In the previous video program, you have studied about ocean circulations in the form of tides, and you have had a general introduction to different forms of oceanic circulations like waves, currents and tides. You have learnt the details of different types of tides and also the factors related to the origin of tides. You have studied different theories related to the origin of tides, and in this video program you will study about factors affecting the ocean currents, distribution of the surface ocean currents, subsurface ocean currents and also the effects of tides and currents. Now you are already aware that tides are vertical movement of the ocean water under the influence of the gravitational forces of sun or moon or any other heavenly body, while ocean currents are the horizontal movement of a mass of oceanic water in a definite direction. So currents are important because they are able to drive oceanic waters to thousands of kilometers, and in this way energy is transferred through mixing and transportation of waters of different temperatures and densities. So what are the factors that affect the movement of ocean currents? So you will get to know in this video program that there are several factors like wind stress, pressure gradient, Coriolis force, temperature, salinity and coastal topography and bottom reliefs of the oceans that affect the movement of ocean currents. Now let us focus on wind stress. You see, it influences not only the direction but also the speed of the ocean currents. Stress on the ocean surface due to which water is dragged. An effect of this stress is directly proportional to the square of the wind speed, and the resultant current speed is 1.5%. The temperature of the air mass and the sea surface also gets affected by the temperature of the overlying winds, due to which the water is directed in a particular direction of the winds. Now, pressure gradient. Difference in the water level of the sea surface at two different places produces pressure gradient force. You see, when in low pressure areas, water will be a high water level compared to the high pressure areas where pressure is exerted on the water surface, it will be low water level. So when the from high pressure areas water is pressed below, and so there is a subsurface current from the high pressure area to the low pressure area, and along the surface this there is the current moves from low pressure areas to the high pressure areas, because so there is always a flow of water from high water level, which is the low pressure area, to the low water level, which is the high pressure area. So you see that this is affected by the atmospheric pressure. When the atmospheric pressure is more at places like subtropical high pressure belt and other areas, it exerts pressure on the oceanic surface, and so water moves from low pressure areas to the high pressure on the surface. The currents move from low pressure area to the high pressure area on the surface, and there is a subsurface current from the high pressure areas to the low pressure areas. This is also affected, the pressure gradient is also affected by precipitation. When there is high precipitation, the volume of water increases, and so level of water increases at those places, and so there again there is a flow of water from high level to the low level of water. And melting of icebergs also leads to the accumulation of water on the surface of oceans, and so this way a pressure gradient is created, and so water moves from high level of water to the low level of water. And due to Coriolis force also, it is the most important force that drags the ocean currents and deflects the currents in a particular direction. And you must have studied about Coriolis force when you studied the block on atmosphere. Like it is due to the rotation of the earth and moving objects like water, wind, etc. gets deflected towards the right in the northern hemisphere and towards the left in the southern hemisphere. So, Coriolis force being little along the equator deflects less water in the lower latitudes compared to the mid latitudes where it becomes stronger. So, when I will explain the pattern of surface ocean currents in the figure, I will explain how the currents get deflected to the right in the northern hemisphere, and so they form a gyre which is clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. Now, how temperature affects the movement of ocean currents? How it affects the movement of ocean currents? Both surface and subsurface movement of ocean currents are affected by temperature. Due to high temperature sea, water expands. Since water expands, it becomes less dense. So, density of water changes in this way, and so when the less dense water, and you see the temperature decreases towards the polar region, so the density of water increases towards the polar areas. So, what happens that the higher density of water presses, and again there is a subsurface current from the higher density of water to the lower density of water, that is from pole towards equatorial regions, and then from equatorial regions there is a surface current from the low density of water to the higher density. So, you see water moves from low density areas to the higher density areas. So, you see there are many currents which move from the equatorial regions to the polar regions, when I will explain the surface distribution of ocean currents of different oceans with the help of figure later in this video program itself. Now, how salinity affects the movement of ocean currents? You see, salinity affects the density of ocean currents, making it denser. If the water is cooler, then it becomes all the more denser if it is more saline. Even warm water is lighter, but if saline, it will become more denser than the fresh melt water. Due to these differences, the subsurface currents are affected, as denser water again sinks, as I have explained in the previous factors also. Denser water sinks and moves as subsurface currents, whereas the less saline water moves towards the area of greater saline water as surface current. So, you see most of the physical properties of ocean like salinity, temperature are driven by the density or the pressure gradient. Most important factors are the pressure gradient and the Coriolis force, which deflects the movement of ocean water, and also one more important factor like coastal topography and bottom reliefs. You see, when the currents are moving in a particular direction, they are obstructed by the coastal topography. You will see when I will explain with the help of maps that it follows the coastlines. Most of the currents are following the coastlines. So, and also the bottom reliefs like mid-oceanic ridges, they also affect the mixing of warm and cold water at wherever they are situated. So, in this way, these are the most important factors which affect the movement of ocean currents. You can just see that wind stress and pressure gradient are created by atmospheric conditions, and pressure gradient is already created by also created by different physical properties like temperature, salinity also, but wind stress is affected by the atmospheric conditions. Now, temperature of the ocean water is also affected by the atmospheric conditions. So, you see, you can categorize the factors on the basis like due to rotation of earth, Coriolis force comes into effect. So, due to rotation of earth, Coriolis force is there, and other properties of the oceans are temperature and salinity. So, you can also categorize the factors. You can get questions in exams like explain the movement of ocean water with the help of different physical properties of the oceans, or explain the movement of ocean water with the help of pressure gradient. So, you will be now able to explain them. Let us come to the general circulation pattern of the ocean currents. As I have explained, the combined effect of all these factors discussed above produces a general circulation pattern of the ocean currents. Large scale circulation in each hemisphere results in the formation of oceanic gyres. As I told you that ocean currents follows the direction of gets deflected due to rotation of earth or Coriolis force that comes into effect, and it deflects to the right in the northern hemisphere and to the left in the southern hemisphere. So, large oceanic gyres are formed which are large rotating systems of ocean currents and are caused mainly by Coriolis effect and large wind movements. They are represented by different names in different oceans for their northern, southern and eastern western arms, and they run clockwise in the northern hemisphere and anti-clockwise in the southern hemisphere. So, and one more thing, when there is divergence of ocean currents, then the upwelling of water occurs, and when there is convergence of ocean currents, then the downwelling of water occurs, and this you should understand while learning this. Let us come to the oceanic currents of Atlantic Ocean. You see, from north equatorial warm current, the red ones are the warm currents and the black ones are the colder currents. So, let us come to the equatorial part of the Atlantic Ocean. You see, since earth rotates from west to east in this direction, earth is rotating, so oceanic currents will move in the opposite direction, that is from east to west. Under the action of this Coriolis effect, they will get when they reach the Brazilian coast, that is the north equatorial warm current, when it reaches the Brazilian coast, it turns northwards and comes as a Gulf Stream along the North American eastern coast of North America, along Florida and all, and you see it gets turned, deflects to the right, and it also follows the coastal topography. So, it is called Gulf Stream along the American coast and North American coast, especially Florida and above, and then it flows across the Atlantic Ocean under the influence of westerlies. It reaches the westerly wind belt, and so it flows throughout the Atlantic Ocean as North Atlantic drift, and then it reaches this is also warm current because of the influence of Gulf Stream. It is a continuity of Gulf Stream, so it is still warm, and this warm current reaches the northwest European coast, and so once it reaches the northwest European coast, it is warm current, so it has a very good effect, warming effect on the European coast, northwest European coast, and due to this several ports like Hammerfest, Murmansk, Gothenburg, they are open almost most of the time of the year. However, along the same latitudes, when you see some ports which are away from the effect of these currents, they are frozen in some part of the year or most of the part of the year. So, it has a warming effect, and it also brings, these currents are onshore currents, so it brings rain also to the northwestern European coastal areas, and then again it deflects to the right. You see, when you see the map, you see it is deflecting again to the right as Canary cold current. Now, Canary cold current becomes cold because it comes from higher latitude and it is relatively cold to the compared to the north equatorial warm current. And similarly, you see another gyre forms along the south Atlantic Ocean, like again the south equatorial warm current flows from eastern part of the ocean to the western part. Once it reaches the Brazilian coast, it comes down, follows the coastline of Brazil as Brazilian warm current, it is warm current, and then it merges with the westerly wind belt as west wind drift, which is cold, relatively colder, and then it again along the African coast, it turns towards the left and it is called as Benguela cold current along the African coast, and then it again reaches and merges with the south equatorial warm current. There are other currents also like Falkland current, which merges with the Brazilian current and originates from the west wind drift. In this way also this oceanic gyre is also present in the Pacific Ocean. You see in the Pacific Ocean, I have in this the world map, you see both sides there is Pacific Ocean, because it is the globe is open from this side. So Pacific Ocean is on the both side. You see the left portion like north equatorial warm current, it turns to the right as Kuroshio warm current. You come to this side of the ocean in the along the Japanese coast, and then it again crosses the Pacific Ocean as North Pacific drift. It is again a warm current, and then when it reaches the American coast, it is relatively cool, and then it again deflects to the right as California cold current. So you see most of the cold currents like Canary cold current, California cold current, they are offshore, and they produce a cooling effect, and they don't bring rains since these currents are cold. So they produce desert conditions along those areas, like Colorado's desert is situated along the California cold current, and you see the Sahara desert is even extended up to the coastline along Canary cold current. Similarly, Benguela cold current in the Atlantic Ocean is responsible for the extension of Kalahari desert even up to the coast. And so in this way, cold currents you see are affecting the temperature conditions and vegetation conditions of the areas where they are visiting. Similarly, the South Pacific also has south equatorial warm current starting from equator and moving towards the Australian coast, and along the coast of Australia it is the East Australian warm current, and then it flows as west wind drift, which is cooler current relatively, and then it again deflects to the left as it is in the southern hemisphere as Peruvian cold current. So Peruvian cold current is also associated with desert along the Peruvian coast, and again this current merges with the south equatorial warm current. So in this way, oceanic gyre is also found in the Indian Ocean, but since the northern part of the Indian Ocean is having more of continental part, so there is also a complete reversal of winds in the Indian Ocean, like it starts like a north equatorial warm current, then Somali current along the coast of Africa, and then there is a complete reversal of winds along in southwest direction, southwest monsoon winds during the summer and northeast monsoon winds during the winter. So there is a very complex division of currents in the Indian Ocean in the northern part. Southern part is relatively similar to the rest of the oceans, where a proper gyre is formed because of the continuity of oceans in the southern part of Indian Ocean. So you see south equatorial warm current, it turns to the left as Mozambique or Agulhas current, and then again turns left as west wind drift, merges with the westerly wind belt, and again it turns to the left along the Australian coast as West Australian cold current, and this is again related to the formation of desert in the western part of Australia, and then this again merges with the south equatorial warm current in the southern part of the Indian Ocean. So I have explained the general circulation pattern of the oceans, and you see there is this circulation pattern, that is in the clockwise in the northern hemisphere and the anti-clockwise in the southern hemisphere, becomes just opposite in the extremely northern and southern latitudes, and they are very complex movements. So you see there is a Labrador cold current that is coming from along the Labrador coast and between Greenland, and it is merging with the Gulf Stream. So you see the Gulf Stream is warm current, and the there is a cold ocean current coming from the northern areas, and so it creates a fog like condition in this ocean, Atlantic Ocean, where they meet. Similar conditions also originate along the northern Pacific Ocean, where Kuroshio warm current merges with the Oyashio cold current, and so there is fog like conditions along the coast of Japan, or especially around Honshu Island, so of Japan. So you see, it is very difficult for navigation purposes. So ocean currents have a great effect, produce so much of favorable conditions and unfavorable conditions also, due to these factors which I have explained. Now let us come to the subsurface ocean currents also. Like oceans have subsurface currents that run beneath the surface and travel at a much slower speed, and this subsurface current is driven by temperature and salinity differences, and therefore this is called thermohaline circulation, because thermo is related to temperature and haline is related to the salinity conditions. Near the surface, you can see in this map that near the surface, sea water begins its travel deep into the ocean in North Atlantic. The downwelling of this water is caused by high levels of evaporation, which cools and increases the salinity of sea water along the North Atlantic. This sea water then moves south along the coast of North and South America until it reaches Antarctica. At Antarctica, the cold and dense water then travels eastwards, joining another deep current that is created by evaporation occurring between Antarctica and the southern tip of South America. And slightly into its eastward voyage, the deep cold flow splits into two currents, one which moves northwards in the middle of the North Pacific and in Indian Ocean off the east coast of Africa. These two currents move from oceanic floor to its surface, creating upwelling. The current then comes near the surface, moving eventually back to the starting point in the North Atlantic, or creating a shallow warm water that circles around Antarctica. One complete circuit of this flow of sea water is estimated to take place in about 1000 years. You will understand this better with the help of this figure, where thermohaline circulation is represented. The red ones are the shallow warm waters and the deep ones are shown in blue color. So effect of ocean currents, I have already explained that they produce the warming effect. The warm ocean currents produce a warming effect wherever they visit, like they are onshore along the northwest coastal areas of Europe, and so many of the ports are open, and they also create fog like conditions due to mixing of warm and cold ocean currents. Besides, ocean currents can also be harnessed for the production of electricity with the help of hydro turbines, windmills, etc. Gulf Stream is a powerful source of energy for Florida's needs of electricity. Fishing industries and ports derive great advantage of favorable ocean currents. Similarly, the cold ocean currents like Canary cold current, Benguela cold current are responsible for the extension of Kalahari and Sahara deserts at their places. Now, effect of tides also, let us also study the effect of tides in this program. Like the tides provide large scale mechanism for the transfer of energy in ocean water. They are a good source of renewable energy in coastal areas having large tidal range. Like Bay of Fundy along the eastern coast of USA experiences very high tides, and along the mouths of rivers, like when tides enter the inlets, they are called flood current, and when they leave, this is called ebb current, and this helps immensely in the movement of ships towards the harbor. Now, in this video program, we have covered the factors related to the movement of ocean currents, and surface, we have discussed the general distribution of surface ocean currents. We have also studied about subsurface ocean currents. Now, you will study these with the help of figures, and your concept will be more clear. and in the next video program we'll study about ocean deposits. Thank you.